geometric horizon.
It
right?
also included how waves propagate
Focus.
onto things. A geometric
Focus.
horizon is
We were
not
talking
going
about
to
the
be
geometric
the last
horizon getting in
point
the way.
that you can pick up a signal
But
on
Solar,
Earth.
he talked about a whole load of other stuff as well, didn't he? About how radio waves propagate, and you've just totally ignored that, and you're still doing.
And how he said it wasn't attenuation, and how he said it wasn't the inverse square of light, and that it was the curvature of the Earth limiting the Lorentz signal.
You're literally repeating what I've just said you're doing. You've just ignored everything he
Repeated
said.
what he said. That's what he said.
He didn't. That was the summary of what he said, I think, or somewhere close to it. But you ignored the stuff he said about different radio wavelengths and how each of them has a number of mitigating circumstances. Was the phrase that he used.
It's a complex interaction that has no nice pigeonholable properties that you can just say it's A, B, and C. That's the problem. The radio waves interact with the surface of the Earth. They interact with the atmosphere. They interact with the ionosphere. This all complicates the idea of the inverse square law propagation from free space. And trying to compare line of frequencies that have more line of sight properties like microwaves with medium frequency propagation is just not going to work. And that is well known from over 100 years of the use of these frequencies.
Okay, and using these frequencies, the whole crux of what we were talking about was that there couldn't be a receiver to send a signal across the ocean or across half the Earth or across vast distances. And then we brought up Loran because there was a signal system for exactly that purpose. Then you said it gets cut off at a certain 500-mile point due to various things, wavelength, due to attenuation, due to curvature, due to all these different things. We're talking about the point at which the geometric horizon starts to block that signal. Now, we can calculate that based on the observer height or the tower height, and it's always the communication ability is
Flat Earth
miles
you are a
further
dishonest son
than
of a bitch.
where
We
that
just went
geometric horizon
We
should
just
be.
went over why the geometric horizon is not the exact limiting end of that signal transmission. You're not listening.
And you can test this shit yourself. Get a radio.
Right. I mean, I can remember as a kid, you could listen, if you listened to the radio at night and fiddled with the tuner, you could pick up radio stations from, I don't know, I can remember picking up North Africa, which to me as a child seemed very impressive. But you couldn't do this. You couldn't do this during the daytime. I think it was only on like summer nights or something you could do this.
Well, the typical example for the UK was Radio Luxembourg, wasn't it? You could not hear Radio Luxembourg would play all the before Radio 1 and 2 was established. Luxembourg would play all the new, all the anti-establishment tracks that the young hipsters wanted to hear. You couldn't hear it during the day, and yet Radio Luxembourg put out from exactly the same antenna, exactly the same power level, 24 hours a day. But you could only hear it in the UK at night because the propagation allowed it.
My VHF radio on my boat, 25 watts or 1,000 watts, won't go much further.
So then I think that answers the point that Fuckett was making earlier, where we were not sure about whether it goes further at night or day. I think it's obvious that it definitely goes further at night when there's less optical or atmospheric conditions causing variation in that part.
Nothing to do with optical or atmospheric conditions. You're trying to pigeonhole everything like microwave and light propagation. You are going to come unstuck, and you are coming unstuck by insisting that everything has these limited properties and abilities. Frequencies, there are frequencies where the converse of the day-night cycle is possible. There are frequencies where long-distance communication is only possible during the middle of the day, contrary to what we've just talked about between UK and Luxembourg. You cannot just simplify the whole thing into your simplistic point of view.
I am going to speak with authority, even though I know nothing.
What happened? Did
To
they?
me, just the fact
Oh.
that atmospheric conditions can cause variation is something that's never factored into your calculations. You
It
stated
is.
that the signal could be received further, that you could only hear that radio at nighttime because some atmospheric condition was allowing that signal to be received further. And then I explained it back to you, and then you say, I'm creating a non sequitur. It's
Radio engineers
I
are fully
don't
aware of
understand.
all of those circumstances and
And
do
you are
have ways
you're
that you can
incorrect to
predict
say
how
atmospheric
long
conditions.
those signals will go. Flat Earth Solar, you're being a dishonest fuck right now.
Yeah,
incorrect
you
because
cannot
you think that
try
there's
to
no
describe
atmospheric difference
atmospheric
between day and night.
conditions to ionospheric conditions. This is the reality is there's more to it than you are trying to say. There are ionospheric conditions that come into play. These are not the same as atmospheric conditions that might affect microwave or light propagation. They are different media. They are different mechanisms through the media over the distance.
And bringing up ionic bouncing or ionic scattering is completely unrelated to the topic of radio frequencies being received at your radio.
'Cause it doesn't
Ionospheric.
radiate.
I mean, the ignorance of the terms
So
is
you
just so
think
illuminating.
that day and night has no atmospheric difference, but yet you can receive the signal further at night
But none of that
for what
crap
purpose?
happens at your radio, you idiot.
I'm not saying it happens at the radio. I'm saying
You
that it
just
can
did.
travel further due to atmospheric conditions, which make it right to travel further.
Ionospheric
It's not the
condition.
curvature of the Earth blocking off that signal,
Yes,
which
it
you
is.
guys are
There's a
claiming.
limit to how much it can refract around or reflect off of an ionosphere. But it
Magically,
definitely
just refracts enough, right?
Well, in
It
actuality, what I
it
could
can
do is
reflect off of the ionosphere. But there's a limit to how
I-
far it can do that. And there are equations and predictions available for you to go and find out how far those things can be. But you won't look any of that up.
So
I
this
could
is the
do this with a
opposite of
physical
magic.
obstruction. I could do this with a physical obstruction. I could take a mountain, and then I could do an ionospheric bounce over the mountain.
We're not talking about bounce. That was the point.
Sometimes we are. That is the point.
Not for radio communication, for
Yeah,
your
yeah.
commercial radio.
The whole of shortwave propagation is predicated on the ionospheric interaction, the reflection from the ground source via a layer high in the sky back down to the ground. Reflection.
I'm going to still speak with authority and tell you what I don't know.
Or
What
never
happened? We lost
researched.
connection.
No, we're just forcing
No,
Simon to think about his words.
No, you guys are talking about multiple different topics, and you just jump from one to the other as it supports that straw man, which no
I
one
don't
is
think
claiming.
we are, Solar. I don't think they are. I think they're talking about how radio waves propagate in the atmosphere, right? And they're talking about
With
the
magical
different ways.
refraction at the end
Well,
that just
but
allows
it's
it to
not.
just happen to curve around a ball which blocked it earlier in the day, but then at
Well-
this certain time it can just magically curve and give us that increased
Well,
range.
you keep saying magically, but as has been
There's
said,
still a limit to
as has been stated, there are equations that describe these effects, and it's entirely predictable. So this is the opposite of magic. There's a fully blown fleshed out explanation that makes accurate predictions on how these phenomena occur. So it's not
like
magic.
a geometric horizon, which should be at a preset distance based on height.
Right,
So if
now
the tower
you're
is X
now
amount
you're
of
switching.
meters tall,
Now you're switching subject.
no,
Yes, you are.
You're talking about
Now
the
you're
curvature
talking about where we see the horizon when we were just talking about radio waves.
where the radio waves are obstructed by the horizon, Jim.
So you're after it's been explained to you probably 4 times now, you're going to pretend that that's the only factor involved here.
It's not the only, but it's the point that has relevance to the flat Earth.
That you've called magical, and that we've just, as I've just pointed out, are the opposite of magic, aren't they?
It's magic because it only occurs in your mind.
When we call something magic, there's never...
Based on 7/6R. That's the only way it occurs in the mind, that it can do this. Those towers are usually 30, 40 meters tall. Some of them can be 50 or more, but they're generally
you're
not
ignoring,
at the height
you're ignoring
to send a signal.
Soli,
to
you're just
500
repeating the
miles
same stuff,
distance.
and you're ignoring what's been presented to you, aren't you? You're pretending again. Hold on, stop.
Once again,
hang on, let me make my
staying on
point.
topic.
Well, let me make my point then. You are pretending that the only factor here is the curvature of the Earth, and that these radio waves should just behave like we expect, light to behave, more or less. And that it's been explained to you repeatedly that there are other factors involved. And you just go back to pretending there are no other factors involved. Why are you doing that? Especially when you've actually referred to those other factors as magical. And now it's like they're not even there. So address the fact that you've called them magical. Address the fact that you dismissed them as magical, and yet we have predictive equations that we can use to describe these phenomena.
So I've been talking about atmospheric conditions causing variation for the entire time I've been here. So I'm certainly not excluding those in any regard. What I was saying to you guys was about line of sight, point-to-point communication, such as microwave or communication. Then it was brought up in terms of after 500 miles, there's curvature, which then blocks the signal, which meant you guys brought up the curvature or the geometric horizon. And then I spoke about the geometric horizon, and you say I'm deflecting. But I've logically followed exactly what we're talking about. And I'm saying your geometric horizon should be way closer than 500 miles to be sending signals. And then at sometimes you can even exceed the 500 miles. And then you put in inverted commas, refraction around a spherical ball, but not just that there could be better attenuation properties allowing it to move further on a flat base.
Well, what evidence do you have to support that? And what evidence do you have about microwave signals going long distances or further than expected?
What evidence do I have for?
Microwave signals. Because you mentioned microwave signals.
Yes, it's the definition inside microwave signals is line of sight point-to-point communication.
Right, but what evidence do you have that these line of sight point-to-point communications are occurring over longer distances than we would expect?
When you start to look up the long distance microwave communications, and they at 200 miles or 200 kilometers plus, and it all goes to such vast distances that
bring the
we
specific
know.
Well, let's see the evidence of this, because we know, for instance, that FE Core have tried at least 2 or is it 3 of these microwave tests and have failed every time. So they obviously bought into the same bullshit that you did. Probably this thing, is it Israel or somewhere like that? Somewhere in the Middle East, isn't it? The example that often gets referred to.
Exalt Wireless, yeah. I know he's going
Like
to
I
pull up
say,
exalt wireless.
regardless of what I present, you guys are going to say it's magically refracting at just the right R
You are the
value
one that keeps
that
saying
we
magical.
expect it to be.
We don't say magical. We say predictive equations that describe the effect. So
No, I bet
why
you
do you
what
keep
Base
saying
on
magical?
7/6, which is
I bet you what
tangible and
happened was
takes
I
no
called out
optical
exactly
effect.
what it was he was going to pull up. And he knows that an exalt wireless example now is a pointless thing to bring up because we all
Right.
know that that exalt wireless example was done at significant elevation, mountaintop to mountaintop. And of course, he's not
Right.
going to bring that now because that would be stupid.
I'm not sure what his issue is with the refraction. It's a well understood.
It was mountaintop to sea level, so it
Negative.
wasn't mountaintop to mountaintop. But yes,
Negative.
there was an altitude. But if there was a curvature and a bulge getting in the way, it would never have been able to travel that distance in the first place.
We're talking about Cyprus, right?
There's so many. This is the point, which makes it so
yeah, that's the
beautiful.
exalt
And
wireless example. The one
keep
you
it
wanted
on-
to bring
let's
that you
keep it
can't
on
bring anymore
Duran,
is on Cyprus.
which we were talking
Those
about.
are both ends of that link are at significant elevation.
Right. That's the one. It is Cyprus.
Incorrect, because Cyprus is an island and it's going down to sea level. So it was from altitude
Yeah, where's the
to sea
transmitter
level.
at? Where's the transmitter at?
It was in the mountain. And then the receiver was at sea level.
Wasn't it?
Yeah.
Both ends were at elevation. Both ends, both sites were at elevation.
Obviously, an elevation, yes, but can you be more specific? Can you provide what that second receiver
Significant
elevation?
elevation.
Well, it was your example that you're about to bring in, although we hijacked it, I will admit. So if
Not
you can
so much-
reference it, go ahead.
We preempt it, maybe, Jim.
Right.
It sounds like if you want to make a very solid, cogent point, why don't you bring to the table the exact elevations of the example you're trying to use as a refutation for radar being able to go further than we expect.
Further than you would expect on a sphere that obstructs that signal.
Sure, yeah. Why don't you provide us with the exact numbers?
He
Oh, the
won't do it.
micro-
He's another ignorant flat earther. He's not prepared to bring any evidence.
And microwave results are now pending on the FE Core website. And yeah, I've read on here, must be on here, that their first two attempts failed and they were going to try some other transmitter or some, I can't remember.
There's some goodies for somebody to look at.
Oh, no.
I'm guessing by the deafening silence from Flat Earth guy over there that he's not planning on bringing any numbers to back up his supposed claim of this.
I was just selecting the
It's gonna be
image.
this one, isn't it?
Bated breath over here, buddy.
$146-mile microwave, right?
All the actions
193 kilometer. I don't know what that is in miles.
It's 124 miles in this one, it looks like.
This is the one that I was referring to that was taken from mountain to basically sea level. I think it's the Aviat network.
And it's sent and received from a 600-meter tower.
Well, this one
that
seems
part
like
of the
it's
Earth has 600-meter sea levels. Yeah.
Well, I mean, we don't know. I don't know how high they are yet.
zero.
but-
Zero. Zero sea level always, you numbnut. So as it shows on this diagram,
How do we know where this was taken?
Cyprus to Lebanon, is that it?
Yeah, that's the one, yeah.
Neither one was at sea level. Right now, post evidence of anybody in the know claiming it was sea level. You made that up.
so far behind the curve with this solar. This was debunked months ago. The guy that presented it was shown to be a flat-out liar, a dishonest twat.
So they have posted Aviat's website, which actually goes through all the details and how they did it and what their communication strength was. And if you guys had any ability to see, you would see that the graph has a flat baseline, and the altitude is always taken from a flat baseline, and that communication is point-to-point line of sight, which it can only be if the baseline was flat, which means that this is a plane that we're on, and you assume a curved baseline every time you start to think about it in your mind. But in reality, it's always off of a flat base, and you're either so much above the sea level or you're at the sea level. And that diagram showed that the signal was being received at about, looks like 200 meters was where that final red line touches that graph. And the gray portion is showing you the elevation above sea level in reference to a flat baseline.
All right, so it's 200 meters above sea level.
Do we say welcome to Flat Earth, guys?
Well, we need to,
Okay, so
check
so now
what he's
take
showing.
observer height. So
But it
take
isn't
observer
at-
height at
but it isn't at-
1600 meters.
But it
Take
isn't
observer
at
height
sea
at
level, is it?
1600 meters.
It isn't at sea level, is it?
So
One's
it's
at
not from
290
mountain to
meters, yeah.
mountain.
Meters.
It wasn't mountain to mountain, and it's going down towards the baseline of
Dude.
zero.
250
which is the
meters
sea
and
level.
1600 meters. It's in your link. Neither one is sea level. 250 meters and 1600 meters.
Total
And
ignorance.
this is not Cyprus to Lebanon, by the way. This is a different one.
Total
So 200
ignorance.
But
meters
again,
above
neither
sea
is sea
level.
level.
Yeah, it
You
is.
no, you're lying. It's in your link.
Yeah, it says
250.
Site A, Las Cruces, is at 1600 meters above mean sea level, and Site B, Dixon Hill, at 250 meters on Roatan Island.
No, that can't be.
I just
That's
want to,
not
I
right.
want to point out the disingenuous nature of him posting the graph while cropping out the comment under it, which basically includes Earth curve as part of the graph chart. So good job.
Well, I don't think that's right though, Jim, because I heard Solar say that both of them. He said both are at sea level. He was very clear about this. So
No,
did,
I
yeah.
said I
He did. I
didn't.
heard him say
said
that.
the one was in the mountain, and the
that did happen.
receiver was near sea level. That's
You
what
said
I
it
said. You guys
wasn't
said
in the mountain.
both were in the mountains.
You said sea level. They're both at sea level. Is what you said earlier.
I
didn't,
I will
but
direct
sure.
you to the actual graph, which shows the microwave path profile, shows antenna elevations and path clearance over effective Earth curve. So using this as some kind of proof of a flat Earth is just nonsense. And I think you know this, which is why you cropped out the
Yeah,
the
you've totally done that. You.
Oh dear, someone's been caught out.
What did I crop out? I was trying to cut the image, and then you said, "Where did this come from?" So I posted the next one, which said the Aviat network.
All right. Well,
I was not
Bizarre did
trying to
post
keep
the
anything
same
out.
one. Well, the same diagram is there somewhere, and it says it's labeled as showing clearance over effective Earth curvature.
Yeah, if you scroll down on the website you provided to us, or that's called reading the link that you provided. You'll see
Sure,
that
and that's those
graph
fictitious
full.
blue lines. You see that those blue lines that have no bearing on anything, the ones that occur in the middle, that would be the path around the effective Earth curvature.
Here's a picture of the microwave site.
But it's actually the red line,
Not
which
quite
is showing
sea
you
level.
the line of sight down toward.
You realize the red line above the blue
the
line is why
island.
it works, right? Like, do you know how to read a graph? If the red line was below the blue line, then it would no worky.
Oopsies.
But the blue line is just conceptual. There's nothing that it has any
If
bearing
it's
toward.
conceptual, then why did they have to take it into account on their graph and when they designed their system? If it's just fucking conceptual, stop being disingenuous.
More importantly, why is this particular link notable? Because it just barely clears curvature. That's why it's notable.
And now that neither elevation is at sea level or near sea level, what's left of your attempted point, Solar, other than your shame, or what should be your shame and embarrassment?
You think 200 meters is not close to sea level?
250 meters? No, not when you're talking about this.
Yeah, it's nearly 800 feet high, right?
Try to have some decency about you. Some.
I mean, I would say 800 feet is a lot.
But certainly not like 3,000 feet like the origination point, right? Because you guys were saying
It's
it was
not a
from
light
mountain
year
to
either,
mountain.
but it's not at sea level.
200 meters above is practically fucking sea level.
250.
250. Close as fucking damn it. It's 2 football fields. It's not like...
If I were to
Two and a half.
drop you off, if I were to drop you out of a plane at near sea level, would you say, yeah, sure, why not?
Starting to swear, Solar. Are you getting scared?
Not getting scared, no.
Maybe you can get away with feeding this bullshit to your flat earth buddies, but it won't cut it here, mate.
So I'm not sure what point you're trying to prove here, Flat. Like, do you provide links, which is great. That's what we asked for. But you provide links that directly refute what you're trying to say.
Well, that would be called doing a gleam.
You flat
Okay,
earth
so
guys
let me-
really got to step up the quality
Let
of
me
the evidence
try
you're
and
trying to
explain.
propose. You
So
flat earth guys
go into
really
the
got to step
curvature
up
calculator.
the quality of the evidence that you present.
1,600 meters is 4,800 feet. Target distance 124 miles, being the 193 kilometers. The horizon distance would be at 84 miles.
Why are you mixing?
From an observer at 4,800 feet high, your geometric horizon should be at 84 miles. And you're sending a signal 120 miles.
Yeah, why are you
And
mixing?
you don't see anything wrong there.
Second, it's not 4,800 feet. You know it's more than that. Third, both
No,
things.
1,600 meters
Both-
is what in feet.
Both ends are elevated. And geometric horizon isn't the only limiting factor.
Well, you claim that it's managing to not be obscured by this geometric horizon, which should be evident at about 84 miles. And this is traveling at least 50% further at 120 miles.
Well, it looks like Dr. Brian Peck showed something that's different from what you just calculated. Would you care to look at his image and tell us where he went wrong and you went right?
$5,249 equals 4,800, don't you know?
You could have kept it all to the same units. I don't know why it's got to be all different units.
So again, flat Earth. I feel like you should just stop providing numbers because the numbers just don't support your argument. But then again, we ask you for numbers because if your argument doesn't have them, then it's just nonsense that we can dismiss.
Okay, so the curve calculator that was just posted now, the Walter Bislin one, shows a bulge height of 665 meters, but it's being received by a receiver at 250 meters. but there's supposed to be 3 times that in terms of obstruction. The amount of hidden,
That's not how.
134.
No. Take the real distance. Take the real height of the transmitter or the receiver, either one, and do the calculation and look at the hidden with the real values.
Oh yeah, and these things are transceivers, so they do both. I don't know why Flat Earth Solar can't get that.
I have a suggestion, Flat Earth. Why don't you drop this particular topic, take the L, and come back later when you have something else.
Well, I don't see how it's an L. With my
Look at the chat.
demonstration there,
Seriously?
I showed where the horizon would be. You're showing me what the relative drop or what the hidden distance should be. That doesn't show where the relative
You can
horizon or
see the
geometric horizon
Look,
should be.
man, you're invoking an area designed by a company that did these calculations. You provided the website from the company that did this. We showed you their calculations take into account Earth curve by the graph you literally posted, and now you're saying no, they're wrong, I'm right, but it still somehow works.
It works because it's line of sight. Their drawing of a circular blue line that has no bearing
You're
to anything in
literally
relation
arguing with
is
your source right
irrelevant.
now. You're
is
arguing with
irrelevant to
your
the point.
source, saying they're wrong, but at the same time saying that it's possible and that they accurately and that they constructed their transmitter to work properly, but that their calculations are wrong.
Called an axiom. So they're working within a set axiom that they're on a sphere, but yet they achieve the same thing on a flat surface, but they're drawing in a curved circular line to try and show that, yes, it might have worked on this presupposed sphere as well. But all of the evidence suggests there is a sea level that's a flat base, and all altitudes are measured against that. And when signals are sent across that, they can be received at significantly longer distances than your ball should ever allow.
For fuck's sake, it's not a presupposed sphere. We have evidence that
One more
it's a sphere.
follow-up to that then, which is what is the limiting factor over a flat plane then that stops it from propagating even further?
Beam attenuation, or the inverse square law of light. That
So
coning
you can just
effect.
add more power to compensate for beam attenuation. And what was the other one?
No, they use repeaters, and then they can recollimate that signal and send it along further on the same trajectory. But
So why
that
can't you
attenuation,
use power and receive further? Why can't you do that?
because no matter how much power you introduce, there's a squaring function, which means the square root of the power. So it's getting inversely squared weaker. So even if I started at 1 million,
There's no square
within a
root,
few
man.
doublings
fuck?
of distances,
No, that's
it's
all
gone
wrong.
to 1/4
There's no square root.
of.
What you could do if you have a certain amount of signal loss is you could boost the power and you would get more signal. So you should be able to get it further by boosting the power. So why can't you do that?
You can get greater signal strength, but it doesn't mean that you're going to not get that same beam divergence.
But that doesn't support your argument, does it?
It does.
No, there's a limit to how far it can go, no matter how much power you put into the thing. So why can't it go further?
So with the Loran signals, they were sending it continent to continent, which is thousands of miles. And if you can achieve a 1,000-mile communication, then effectively it is able to be done further.
Citation needed.
There is a woman who
Not
was
all
involved in the
continents
British
are thousands
communication.
and thousands of miles apart. Not all continents are thousands and thousands of miles apart.
We also
I
know
think
where
this
all the
was sent from
Loran
North America to Europe.
we also know where
That's
all the Loran
is.
transmitters are. There's no surprise Loran transmitters out there. There's not a hidden one or whatever. We know where they are.
I didn't say they were hidden.
But they don't go all the way across
Yes.
thousands of miles, do they?
They did. The transatlantic signal that was sent via Loran just before the Second World War is probably the most famous one. It was sent from North America to Europe. So, yes, they do have it. They've just decided that they wanted to do short-range communication, probably to boost signal strength going forward.
Well, that's cool.
There's
Then we can
atmospheric
transmit any distance
conditions.
we want. That's cool. Then we can just transmit any distance we want
So
with very
on
low power
signal,
transmitters.
well, one of the guys mentioned it earlier that it's got to do with the propagation wave that you select, because certain waves travel further in day conditions, certain travel further in night conditions. Your
Loran only works at one
ultraviolet.
frequency. They don't have a
Yeah,
bunch
but
of
you were
different
asking,
frequencies for Loran.
but you are asking, can we send it further? So in that specific frequency, which has those limitations, no, but there are other frequencies which can be used, was my point.
You're such a Nimrod.
Your point is that if there's curvature of the earth, there should never be any signal
No.
able to be sent further.
No.
Oh God, the resolution on that transatlantic anything was horribly inaccurate. You could get far better signal or far better resolution out of GPS, which, by the way, you can tell the difference between receiving a Loran signal and a GPS signal. It's pretty easy.
Because they work fundamentally different, and you can see the inner workings.
Yes, not to mention the or I will mention the Doppler of the transmission source. You can see how fast it's going.
Oh, I didn't think about that. Yeah.
All of which don't address the point that you can actually see further than you should. You can send signals further than you should.
No,
Based on a curvature.
Nothing is further than
Because
you
what
should.
happens is when you receive a GPS signal and it's Doppler shifted by an amount of something that's moving thousands of miles an hour, that's not something that you're just going to explain away by a ground station.
Maybe the ground is moving.
The ground's moving at thousands of miles an hour, sure.
Refine your arguments to more than further than you should. That's so inaccurate. We don't know where you're coming from with that sort of statement.
You know, he wants to say the geometric horizon, which we all know already doesn't mean that's exactly where things end.
Doesn't exist, correct?
No, it doesn't mean that that's where things end. We already know that refraction and reflection are both things.
A common misconception is that the geometric horizon doesn't exist and that you never see it. Yes, under most situations and observations, you don't actually see it, you see the apparent horizon. However, there are times when the refraction and all the cumulative effects are neutral and you do actually see the geometric horizon.
I'd say that's as rare as hen's teeth.
Yeah, it is super rare, but it's a misconception that it's never.
It's just more often than not seen 10 times further. I agree. And there's only one horizon. There's not an apparent and a geometric. There is only one, and it is the apparent location. And that's why you guys keep calling it an apparent versus geometric. In the actual definition, it says where the sky appears to meet the ground. And
Well,
Nathan tried to make the
10 times
distinction,
further.
and now you guys have had latched on that there's two.
The 10 times further claim doesn't actually address how refraction actually works. It's an angular displacement. It's not a linear across the ground displacement. In the example of the black swan, that displacement is less than a degree by a lot. It's actually probably closer to 0.1 degrees. That amount of refraction is something very much expected within our atmosphere.
That's a bit incorrect to try and stipulate that there's two horizons, due to the fact that there's a multitude of effects, refraction being one of them, that actually affect where the location of the apparent horizon is. And because of this constant shifting of trying, makes it malformed to stipulate that, oh, there's just one apparent horizon and one geometric horizon.
And it's worth mentioning that refraction isn't some magical black box flat earthers like to make it out to be. Like, you can use different wavelengths of light to determine how much refraction there is. You can use just plain old air temperature, pressure, humidity, all that kind of cool stuff to figure out how much refraction there is. And it all works. But flat earthers don't like to, address that point.
Yeah, but Doofus, where is that geometric horizon? We've never ever located it. Ever.
Here you go again, and I've already explained it to you. I'll actually just share the video. I'll share the video of
You,
me talking.
but you just said it's hardly it's so rare. It's so incredibly rare to see the actual physicality of the realm that I stay on.
Yeah, that's because
And
it's
most
so rare
times
that we
it's
don't have
not
an atmosphere around
showing.
it.
Most times it's not showing what I believe, but I just believe it anyway. That's what you're saying.
No, what he's saying is
We
that
as
we
flat
always live
earthers
in an atmosphere,
always
so
see it flat.
asking for something that requires no atmosphere in order to see is silly. But you can go up in elevation and reduce the air for where it would be on any given day in any given condition.
You
Your
live
problem
in a
is
realm
if you
on
go
a
up too
planet.
high, then you'll start seeing the curve the further away you go. So either way, you're shot in the foot and you're done.
What we'll see curve, is that curve physical, like geometrical, or just like an illusion? That's the question here, because
shared in the chat of you and me talking about refraction and a special bonus, lights in the sky, because that's a stupid argument.
I don't want to talk about refraction. I want to talk about the
and
physical.
I've also tagged solar in there just so he can peruse it as well.
Yeah, but we don't want to talk about refraction or light. We want to know the physical drop, the physical earth, the physical geometric point. Where is that ever?
It's always beneath your feet, Chemo, wherever you're walking.
We're talking about if you're a 1 foot observer. Where is that geometrical, even a 6 foot observer, where is that geometrical, always in the same place drop? Like if we go to a hill, that hill will have the same drop as it does today and tomorrow, unless of course, there's an earthquake, but generally the hills, or a mountain has the same drop. Never because of refraction that drop changes. We don't talk like that.
Right. You're right. You're totally right. That drop will not change due to refraction, but what you see of that drop will change due to refraction.
No, I'm saying if you get the top of a mountain and it drops down from the top to the bottom, that drop will always be the same and it'll always be in the same place. You won't say, oh, refraction is made.
What you see of that is going to be mitigated by refraction.
Not getting it, are you?
We're pretty sure
because we've already had this discussion at length. I posted a video of one of those discussions, and there it is. Just go ahead and re-educate yourself.
No, we're looking for...
You'll never experience a difference in drop on a mountain. The mountain will always drop equivalently. When you stand at this position, it will obstruct those things always.
Always, yeah, physically. Not light, no bending stuff. We want to know where is the physical drop from an observer's
But how
point.
much you see of it is still going to be affected by refraction.
Still not getting it. When a ship goes over the horizon, is that physical?
Timo, you're shooting your argument in the foot here. Because if you claim that mountains, for example, can't refract light when you look at them, then you're saying that Whitsett is wrong in his debate with Ranty as the reason for the mountains appearing lower than Blackpool Tower is due to distance away and refraction.
I don't mean that. Again, you still not get it.
You need to think about what you're saying before you just start spouting off nonsense that blows up your arguments.
You need to listen to what's being said. I said if you were on the mountain, on the top of a mountain, actually on it, the drop down to the bottom will always be the same. That will never change. So as you look down the mountain, that drop you're looking down will always remain the same. So if the same with curvature, if you're 1 foot and there's a drop, physical drop, that drop will always remain the same. Not because of light, not because of any refraction. The physical drop will remain the same. But we never find that. A ship goes over the horizon at, say, 1 mile, it drops. we never see that same drop at 1 mile the next day, or even on the same day. We see the drop further away. The boat starts to drop further away.
Chemo, you just made two separate arguments that were not related yet again. Physicality, the geometry of something. Then you went to optics again, which includes refraction. Anything you do optically, you must include refraction.
No.
If you say something about some distant boat that's being obscured or not by some amount of horizon or geometric land, anything, you are going to have to include refraction. You can't ignore it to make an argument. It doesn't work.
So if we're building a building, we must take into consideration refraction.
If you're going to measure the height of that building from a distance,
It hasn't been
you
built
are
yet.
going to have to take account of that
It
refraction.
hasn't been built yet. We're building a building.
Yeah, and
He's
you don't
talking
include refraction
tangible,
to build it on the
and
ground.
and
However,
we are
when
building.
you
just
start
proven
mentioning something
that you're
like
not
something
understanding.
in the distance that is obstructed, what you're going to have to include every single time is refraction.
So if I'm building a building from Ranty's observation to the mountains, I would have to include refraction in my building project.
No, because when you're building a building, you don't build it from frickin' 80 kilometers away. That doesn't make any sense.
You could do if I was making a canal that long.
Yeah.
Are you making a canal that long?
Would I need to take into refraction if I'm building a canal that long?
Do you ever have to take refraction into account?
Well, that's
when
what
you're building
Doofus is
something
saying.
and
When
you're
something
at
is
the
physical,
location
I
you're
need to
building it?
take into account refraction.
No.
Chemo,
Not
do you
when
take into
building
account
something
refraction
tangible.
when you are building something right in front of you?
Yeah, if I'm building an 80-kilometer canal, do I need to take in consideration refraction?
No.
Exactly.
If you're going to survey the site, you can.
You measure it and you make sure that it's level
what
to contain
is the
the
point you're
water,
trying
which
to
will be
make?
level.
Yeah, and if you're going to survey the site, you are going to include refraction.
Because I'm talking about physical drop. If I'm building my canal from Ranty's observation to the mountain, and then it drops down at the mountain, I need to know how much it's dropping by. Because that will be the same
I'll
drop
use-
every
Not
single
just
day.
dropping
the
down at the
exact
mountain,
same
it's
reference
dropping
last time
down
that I told this
all
to you,
along the way.
which is that back when they were testing atomic bombs, they contracted someone to build a pipe with a detector at the end so that they could measure the amount of radiation that their atomic bombs would do underwater. So they contracted someone to build a pipe, a straight pipe, that they would then have the detector on the end so that it would be a safe distance away from the detonation. They did this, and the person that built the pipe took curve into account, and they got 0 readings through the pipe. And they're like, huh, well, that's weird. Why didn't we detect anything? Oh, it's because we built it level, not straight. So they had to go back and have them build a straight pipe before they got a measurement through it when they detonated the bombs. So
Yeah, I
the
think-
point
Yeah, I
being
don't
that you
believe that.
can
You
build
demonstrate that.
something
There's
physical,
no reason
and
to
it
believe that.
still
You've got no
matters.
evidence
I
to
think the
prove
most
that
valuable
is true.
quote
So,
was,
Doofus,
"Oh
if
my
I was going to
goodness,
build a
I've got
horizontal
picture."
plane
almost
to
done. I
that
was
drop,
almost done.
if I was going to build a
You almost
horizontal
made it.
plane to that drop, Doofus, and I saw the mountain dropping, would I need to take into account refraction?
Hey, Chemo just ignored
I
everything
just said I don't
said, so
believe
just
your
keep ignoring
story.
evidence,
I
Chemo.
just said I don't believe
Keep
your
ignoring
story. I didn't
evidence.
ignore it. I said I don't believe you. Provide evidence that they took into account curvature, show the building, show the blueprints, and then I'll believe you. But right now you're just making the story up. So Doofus, if we were to make a horizontal plane to where we see drop,
Chemo, you never provide information. Shut the fuck up.
would we have to take into account refraction if we're going to build a canal from Ranty's observation to that drop?
The canal is going to follow the curvature of the Earth, and surveying the area is going to include refraction.
So let's try again.
So-
If I'm going to build a horizontal plane from the observer to that drop, the visible drop that I can see, do I have to take into account refraction?
As I was already answering, the horizontal plane is not what the canal is going to follow.
But I'm going to build one to follow the horizontal to that drop.
Why would you do that? The water would never cross the middle of it.
Yeah, but I want to build a horizontal plane to that drop and then calculate how much drop it is there so it's the same every single time.
No canal over that distance ever follows a horizontal plane.
You saying I couldn't create a pipe that goes that long and control whether it drops or follows the curve or not?
Had you listened to Nidhug's example, you would know that wouldn't work.
So you're saying I cannot
The
force...
Suez Canal
hold on,
The
hold on,
Suez
hold on,
Canal
hold
is
on,
the
hold on.
same
Are
sea
you
level
saying that I
both
cannot
sides.
force the line and get those pipes how I want them to be? Or is it going to just follow the curve?
They wouldn't work straight. You'd have to have some curve in there.
That's what I'm asking you. We cannot force the line, is what you're saying.
A canal, yeah, you cannot have a perfectly straight canal. It has to be following the curvature of the earth.
I was talking about a pipe.
Okay, what are you going to do with a pipe? If you're pumping it, the exact shape of it may not be important.
Yeah, so I'm going to have it not following the curve. Is that not possible to do?
How big of a pump do you want to build?
I just told you, from Ranty's observation to that
when you
drop.
could rather just do this with no pump at all and just make a canal.
Pump, just a pipe. Gonna get the pipe first, an oil pipe.
If you're gonna build a pipe, Chemo, you're not gonna build another straight, slack-like pipe.
But I'm asking, can I build it so it doesn't follow the curve? Or do I have to follow the curve every time?
What do you mean you have fucking have to? You always follow it. You're on the surface of the earth, you idiot.
But Doofus, could I build it?
It's like saying, do I have to stick to earth?
Could I engineer it, Doofus, so it doesn't follow the curve?
Yeah, you can. It would be completely useless.
Why?
Because the earth is not flat.
But we're not doing that for that. I'm asking you, could I create a horizontal from Ranty's point to that drop and force the line so it doesn't follow the curve?
Yeah, you
There's
could do
only
that.
one
But
building
what
in
would
the
you do
world that does
for?
that, Chemo.
You
Slack.
wouldn't do that to, transport any liquids. It would be completely useless. Why would you do that?
So I'm asking, if I build the pipe and it's forced the line, you're saying as soon as I put water on it, it will just break and follow the curve?
The liquid will follow the curve, because that's what liquids on Earth do.
So if we make a device, this is hilarious. So if I make a device,
Liquids
Doofus,
follow
from
the
Ranty's
curve.
point to the drop, where it's completely horizontal, no water, and then I pour water in it to go along the pipe, you're saying it will follow the curve?
It will pool up in the middle of the pipe.
And follow the curve, yeah?
That's where it's going to want to be at its lowest elevation, because a straight line over a curved surface, over a convex surface, the lowest point in elevation is going to be the middle.
Yeah, but what I'm asking you, can I build something to avoid all of that? Can I build a horizontal to avoid all of that?
Build a particle
Can't be straight.
accelerator, a linear one.
It's not
Continue.
possible to build a straight device on a round Earth. There you go, Solar.
No, it's that, as I said, it can be straight, but it won't be good for transporting liquids without a pump or some other form of power, of force.
Yeah, if I pour water on it, you're saying it will just collapse and follow the curve.
Not collapse, just head toward the middle.
Okay. So it can be done.
And it would be pointless.
No, there would be a point.
Well, but if you built it level, wouldn't the water just bulge in the middle like it does in the oceans? So even if it was level or to the surface of the earth, it would still bulge in the middle, right?
Level is not a straight line.
Are you just thinking that level means that there is a mountain of water in front of you?
If you're a baller, you have to assume that level is curved, and curved means there's a
No,
hump of water.
we don't have to assume that. We can just point out this ridiculous notion that you have in your head. We don't have to assume that level is that.
You're saying between
reciprocal zenith angle measurements do show that level is curved.
Doofus, you're saying between Ranty's observation
Incorrect.
point and the mountain, there is a hump of water raised up.
No. No.
Ranty's observation, the thing is all below high tide or below mean tide anyway. But
No, but I'm talking
you're
about my
looking
pipe.
over land to land, so it doesn't really matter where the
Tell
water
me
is.
why the pipe would bulge, the water would bulge in the middle.
If you build a straight line pipe over a curved surface, such as the Earth, and you do it such the midpoint is at the lowest elevation above that curved surface, that's where the water's going to go.
Yeah, so you're saying there'll be an obstruction, a bulge between the two observers.
There always is.
Incorrect to say a bulge.
Well, Doofus is saying
You know
bulge. He's happy with the fact that the water will pile in the middle.
I'm going with your terminology. You could say bulge. What I could say is sagitta, which is the correct term.
Sagittas are a good one, yeah. So there's a sagitta between the two observers is what you would say.
Yep, and the between the two endpoints of equal elevation, that's called a chord. I'm going to have to try to educate you on
What was
terms.
Ranty's height?
What?
What was the height of Ranty? Out there.
Of Ranty?
Yeah, on his picture, the Blackpool picture.
Which one? The one that he got from the photographer?
Or which one? Whatever one he used. What was the height?
The observer is about 10 meters above the water level.
10 meters height, observer height, yeah?
Thereabouts, above the water level.
Okay, so where is that geometric horizon for that observer? Well, 10 feet.
Pretty useless because most of that observation is over
12
land,
miles.
which has many different elevations along that, along that line of sight.
What, isn't he looking over water?
There's a tiny bit of water directly in front of the camera, sure, but most of that picture is land.
Okay, so
almost the entire thing is land. It's like 95% of the thing is we were looking at land or the sky.
And no geometric horizon at 12 miles as it should be from a 10-foot observer height.
It's not 10 foot. I said 10 meter. You're not paying attention.
So what's that, 33 feet?
10 meters.
So he was 33 feet, what you're saying. Doofus. Was Ranty 33 feet in the air?
In it, oh my God, there's an elevation of the ground he was standing on. The camera is also not right on the ground, and the water is at low tide.
Was he 10 meters or 33 feet?
Above the elevation of the water? Yeah, about 10 meters.
33 feet?
Yeah.
He never said he said he was 12 feet.
I didn't say anything about 12 feet.
Where did you get the 33 feet from?
From the particulars of the observation, from the fact that it's low tide, from the fact that the place that they're standing on is 6 meters above mean sea level. But of course, low tide, you add that, and then you also add the height of the observer.
Sorry, run that again. You did what? How did you get the height of 33 feet?
So 6 meters is the elevation of the area where the photo was shot from. Then you add in, for elevation above the water, you add in the fact that it's a low tide. Then you also add in the observer's height. You got all that together, it's about 10 meters. It's about 9.5.
So we don't have the observer's height, though.
What did I just say?
That you calculated it. And about this, maybe that, maybe.
The 6 meter elevation is not about anything. The about 2 meters of, well, okay, so we'll say about 2 meters
Come on, doofus.
Of water level below the mean sea level, and 1.5 meters of the camera height above the ground, which we already determined was 6 meters above mean sea level, which is already another 2 meters above the water.
Ranty never said anything about being 30 feet in the air.
When you say 30 feet in the air, what you're implying is the camera is 30 feet from its location to the ground, and that's not what I'm saying at all.
I asked you for the observer height. You said 30 feet.
Above the level of the water in the surrounding location.
That's the first time I've heard this number. 30 feet.
It's about, well, it's closer to 31. It's 9.5 meters, or 30 feet.
Doofus, if you're going to make things up, how can we have an honest discussion?
These are not figures that I came up with. They're figures that were all in the presentation about a month ago now that you decided you didn't want to watch.
How can we have an honest conversation, Chemo, when you just make stuff up?
Well, what's the height? Nobody knows.
9.5 meters is the height.
Is your guesstimate?
No. If you watched the original presentation from almost a month ago now, is it about a month ago? Somewhere around there. You haven't watched it yet. It's only an hour long.
The video.
Ranty's
all we need is the height
and Ranty's portion
and
of that. And Ranty's portion of that was only about 15 minutes long. I think it was actually less than that. And for nobody to have seen that yet out of the flat Earth community is extremely disappointing.
No one's going to watch that because, like I said, all we need to know is the height, what he was looking at.
Flat Earthers can't watch YouTube videos. What does the world come to?
We don't even know the height.
15 minutes. I mean, a whole 15-minute segment of a 1-hour video, it's just too
I
much. But
argue
they'll
with
sit
flat
around
earthers.
On Nathan Oakley live stream for 3 hours.
Right,
There's
like
something
I'll
really
argue with a
wrong
flat
with this
earther and he's like,
picture.
here, watch this 4-hour-long video that says I'm right. And I'm like, are you fucking serious? Can you summarize? Meanwhile, Ranty has a 15-minute-long segment and an hour-long video that flat earthers straight up refuse to watch.
Anyway, we know the height, Solar. What was the height? It was around 12 feet or something? What was it?
Why
10?
learn in the video? Why learn in the video when you already know everything?
Yeah,
you
you know the
included in
distance
that
of where the
15-minute
geometric
stint
horizon was
is,
supposed to be.
included in that
suddenly like,
15-minute
oh,
stint is an explanation from Ranty himself, exactly how much you can see of those mountains that are just are how much you can tell of that mountain is visibly gone. That cannot be accounted for by the town obscuring it at all. It's over 300 meters.
Everyone just heard you say you can't build a horizontal from Ranty's point to that drop.
No, that's not what I said. I didn't say that at all. What I said was you could, it would be completely pointless.
Well, no, it would give us a fixed location. We would know that the drop, Earth drop, happens from that place, from this place, every time. Without
And you would
refraction.
deny the evidence of how that straight line was formed.
Force in the line. Don't you understand how to do engineering?
You would deny the forced line because it's complex how you build it. You would just say it was not straight.
It's not complex for an engineer.
I hate to tell you this,
It is
Timo, but there are actually
complex.
websites for people like tile layers that have to know how to make a level tile versus straight tile when they're doing DIY or construction work. Like the difference between level and flat is well known in anything, engineering or otherwise. You're just straight up refusing it.
Well, again, we were just asking Doofus here if it was possible to
But
construct,
again, just hand wave it.
construct a
Just hand wave it.
structure.
It's fine.
Because you're not on topic here, Nidhogg. We're
Knowing
talking about-
the difference between a level line and a straight line.
Yeah, you're talking from your globe side. We don't agree that level means curved.
Observer to the mountains.
No one knows that. If we have a level, auto level,
Everyone but you knows it, Chemo.
well, can you
Don't
demonstrate then
misrepresent
that level is curved? No, you can't. You can only demonstrate that
Easily.
level is
You can
horizontal.
easily demonstrate level is curved. You can get a compass, draw a circle on a piece of paper, and then change your compass to an extra ½ inch out and draw another circle, and those two circles will be level with respect to each other. The lines that you've drawn. Easy. A second grader could do this.
No, that's a curved line. That's not level.
It's a level line, Chemo. That's the definition of level.
No,
It
level
doesn't
means
change
Level is no
horizontal.
side being
from
higher
one
than
line to
another.
another.
Level is no side being higher than another.
Exactly. Level means horizontal. Also.
See, again, you're just straight up wrong, Chemo. Or
Well, demonstrate
cherry-picking
then that level
what
means
you think
curved.
level is.
Show me a demonstration of level being curved.
Just did. I just explained it to you, and you can do it yourself. I think you're a big boy. You can use a compass and a pencil.
That's not a demonstrate. That's a curved line, not a level line.
The lines that you draw will be level with respect to each other.
No,
To
that
say
won't be a-
otherwise is nonsense.
that won't be a straight, level, horizontal line.
You didn't. I didn't say straight level. I
Oh.
just said level.
Yeah, level is straight and horizontal.
You're incorrect because I can draw two circles that are level with each other. So you are wrong.
They are not on the same level.
They are. They do not deviate with respect to each other. Therefore, they are level.
So they're not on the same level. We're talking about
You're
one
just-
line,
you're just
not
being
two
stupid.
lines.
You're just being stupid. Chemo.
Yeah, we're talking about horizontal. Straight line. That is level.
You're arguing to argue. You are wrong, Chemo. Just
A
just-
radius is not level. You're saying a radius is level and a radius is not level. Keeping it
Exactly.
equidistant from a center does not make it level. Level is only flat and one side not being higher than another. This isn't
You are
hard.
incorrect. And if you
Level
think you are
isn't
correct,
flat.
you can easily provide a citation for that, but you
No,
can't because
all
that's
your
not what
citations-
level is.
Equidistant from center is not level.
Any
According
of
to
your
surveyors, it
citations
is.
are from the globe
Didn't
side,
say
which needs to be
equidistant from
reviewed.
center. Now, did I? I said the two lines with respect to each other are level.
The two circles was your exact quote, I think. You said you can draw two
The two
circles that are
lines,
level.
the two lines that form the circle are level with respect to each
A
other.
line is not
It's not a hard
curved.
concept.
Lines don't curve.
Incorrect.
That's incorrect, Chemo.
No, that's
As just
correct.
pointed out, you can take a line and actually make a circle out of it.
It's a now
And it is
curved line.
curved in an additional dimension, which if you take that circle and then you rotate it so you're looking at it only in the one-dimensional aspect, it will still be the line.
Yeah, that's not where we live. We live.
No, that is absolutely where we live, is in a three-dimensional world.
Not
So
on a
we
piece
have
of paper.
multiple lines that are curved in additional dimensions.
There are no curved lines when we go outside and water is level. There's nothing curving here.
Every wave's curved.
The water is
Actually-
horizontal because you would need a force to curve the water. And we know there is no forces that can curve the water, large bodies of water around an exterior scientifically. Haven't proved.
Do
So
you
until
at
we can-
least understand or admit
Yeah, I get what
that
you're
your
saying.
view out to the water
Yeah.
is actually a circle?
Yeah, I hear what you're saying, but that's in terms if you have forces acting on the horizontal, then you'll have a curved line, which we don't have because you don't have that force.
The observation is actually that the water on the horizon is curving in the additional dimension that you are not actually taking into consideration.
No, you see a straight line at the horizon, and then you see things disappear behind
Correct.
the apparent.
However, it's curving in the additional dimension that you are not taking into account.
Nothing is curving in an addition.
That is abundantly incorrect, and you know it.
Well, can you demonstrate the curvature?
The curvature and the example of the circle. You
Not
draw
talking
the
about a piece of
circle,
paper, we're
and then
talking
you
about the real
rotate it
world.
so that you're looking at it edgewise. It'll be a straight line that is curved in an additional dimension.
Yeah, well, again, I'm not. I cannot enter into your fantasy world, your realm.
It's reality.
Yeah,
It's
if it's
not a
reality,
fantasy.
then you should be able to show water curving around the
You
exterior.
can do
of an
this, but you won't do it because it actually makes your conclusions fall apart.
I won't do it. No, your claim is that water.
Correct. See, you won't do it.
I won't do that.
That
No.
is a fundamental problem that you need to address for yourself.
Well, once I see curving water, then yes, I will address that claim.
It's not a claim, it's a statement of reality.
So you keep saying, but you can't demonstrate.
Actually, you are refusing to actually do the demonstration and pay attention to it.
Not my
That's
claim.
the problem.
Your claim, you demonstrate.
Your claim is to provide a demonstration. It's just been explained to you how to do it, and you are refusing.
I can
That's
explain
upon
to you how the flat Earth works. Does it mean it's real to you?
Actually, no, you can't, because you've been asked multiple times to explain that, and you have done nothing
What
but
don't you
run away
understand
from
about
it.
the flat Earth? I'll explain everything.
Okay, then start explaining.
What do you need to know about the flat Earth?
You said
Oh,
everything.
give us
so
a
you
working
pick
map
something
or
and you
something.
just start explaining it.
What do you need to know?
A map, for example.
Okay, let me provide that for you.
How big is the flat Earth? North to south and east to west?
Get all that information.
Well, how can it be big east to west if it's a flat Earth?
Get all that information for you.
How about you give
I think we
one
should
piece
wait
of
for Pino to get
information,
that
Kimo? A working
think-
map. Not a drawing, not some kind of shitty imaginary artist's impression, but a working map.
Yeah, this is a working.
I think it's unfair. We're overloading him here. He said he's going to go and get
That's an
this
artist's
information.
impression.
No,
One second.
that is scientifically accurate.
He's going
and
to
hold on a
he's going to
second,
go and get
Chris.
this
Hold on a
information
second,
now, so we
Chris.
shouldn't clock block
Chris,
him.
you're over talking it again. So this map here tells us that it's scientifically accurate. So for you to tell me that this is not a representation, yeah. If you read at the top, look here what it says. Tells us here, this is scientifically and practically correct. So it's got all. Yeah, it's got all the distances, all the landmarks, all the areas that you need to know if you need to navigate via aeroplane or boat, anything like that.
Really, Kimo, it's accurate, right? So take a good long look at Australia in this map and at Canada. Do you think these sizes and distances are accurate?
Show me your version of Canada and Australia. Let's compare.
Google Earth.
Give us a look. Give us a look at your image.
Mercator
Google Earth.
projection is just as inaccurate. So is the Gauls, Peter. So
No,
any flat
hold
map,
on,
any
Solar.
flat map that's
Hold
usable
on,
is
Solar.
flat.
Let Kimo dig out himself out of the goal.
Well,
out
I'm
of the hole
listening.
that he put
I've
himself
asked
in.
you compared to what? Give us a look at your Australia and Canada, and we can compare where it's wrong. And I want to see if yours is scientifically accurate. If it's not scientifically accurate, then we can't use it.
Oh, like flat Earth.
It's
My
something
map-
that's historically
my
been
map
called
says-
coastline navigation.
My map says scientifically
Coastline navigation.
no.
It's actual observations.
Look, stop asking me for more.
By those
Pull out your
navigating
map.
the coastlines.
Pull out your map
and
and let's
those measurements do not match.
Okay, fine. Let's have a look at your map.
That's not what was
I
stated.
sent you
and
a
know
link,
it.
Kimo.
All right, so you've sent me Google Earth, yeah? That,
Yeah.
Actually, a
that
globe-
looks like
a
it's
globe is a
curving
better
to me.
representation.
Redox, that
Your
looks like
standard globe
your
is a
map
better
looks like it's
representation.
curving. What's the rate of this curvature you're showing here?
Can you open the fucking link?
Yes, Google Earth. I've got it here right now.
All right. Now look at Australia on a globe and look at Canada.
Yes, it's stretched over a globe. Let me show you what they did to get the wrong size of Australia.
Hold on. Don't fucking get your horses too far.
Well, what? What's the problem?
We are asking a question. Which is the accurate representation of Australia sizes relative to Canada size?
One that says scientifically and practically
The
accurate.
one that fucking says that. Seriously.
Yeah, science. Well, you're denying science now?
I'm certainly denying your ridiculous notion of it. You don't know what science is.
Well, where is your map that says scientifically accurate?
Are you
want me
fucking
to
stupid?
Oh,
You say that the map
ad-homs.
has to say scientifically accurate,
Yeah,
and
where's
that's
your-
how you determine its truthfulness?
I'm asking you, who's backing your map with science and its accuracy and its practicality? My map here says it's practical, scientifically, and it's accurately correct. What more do you need?
And it's actually
It sa-
wrong in the size of Canada and Australia.
Again, if you stretch or
Hey,
distort...
Kimo, what happens when you give me a wrong map with wrong sizes and you tell me that's scientifically accurate? What do you think happens then?
Because yours is not scientific. Yours is...
Kimo, what the fuck happens when you give someone something wrong and then you say it's scientifically accurate?
Tell me, go on.
Well, I'm asking you. You should know this because you're familiar with science.
Oh, I found it. The picture I was looking for. So look, take a
If
look.
you get a globe, every measurement on a globe will work. They will be accurate, and nobody has shown it to be inaccurate.
So he wants to know why.
Here's the map for you,
Why
Kimo.
Australia is the wrong size and stuff. Right, this is why. I'll show you why. Take a look at this picture here.
It's not wrong on the globe.
Yes, This is why, because when you
No.
take a flat map and project it onto a globe, you've got to stretch, distort, shrink, remove, do all kinds of things to
Yeah,
make
but
it.
once you do that, it's accurate. It actually yields accurate information,
No,
geographically and inch for inch accurate.
no, the military use a flat map. The Navy use.
I don't give a fuck. The globe actually gives you a correct answer every time.
Well, again,
A flat map does not give you the correct answer every time. You have to use adjustments and calculations and all this other shit in order to get the right answer. But a globe just works.
you're just arguing for
The
argument's sake.
scale
Where
works
is
on
your
every
map?
square inch of the globe. A scale works.
Okay, I notice you're attacking my map, and where is your map and model?
The globe.
Yeah, and
We
I've just
sent
told,
you
I've just told you
fucking
that
link.
was
You open
distorted.
it.
That's distortion.
Nope, not distorted. It's accurate.
No, it's showing.
Show me where it's distorted. Where is it distorted? Show
How
me
does the
distortion in
water
globe.
stay on that ball? Look at my model where the water stays in the middle.
Distortion in the placement of the
His fucking thing in the water should just slide down.
Look at the water in my model, Moya.
Even my satellite image shows the bushfires we had here, which
All right, Terry.
was accurate.
Chemo, in the model of Earth, what is the direction of gravity? Do you think it is down to Antarctica, or do you think it's to the center of the Earth?
On a flat plane, there is no gravity.
So, Chemo, you fuckface. Unmute drop.
Oh, yes. But it's supposed to be. Yes, now look at my model, my map here. Okay, we can see that the water sits in the middle. Now, you've shown your ball. Explain how the water stays on your model. How does that happen?
Gravity, you idiot.
Okay,
Towards the
okay.
center of the Earth.
Okay.
Have you heard of it?
I've heard of it. Give me an experiment to go with your hypothesis.
Cavendish. Mass attracts mass.
So why have
One
you, why
back in the
does
freaking, I don't know.
What?
Which century was that?
Why doesn't Cavendish work in a vacuum?
Why
do you
are you
say it
pretending it doesn't?
What, it does? Let's have a look. Let's see it then, if you say it does.
No, you made the positive claim, Chemo, that it doesn't. Can you show me the experiment you've done to show that it didn't work, or are you lying?
Well, no, I asked Redox if it's been done. He said, why are you pretending it hasn't been done? So he's obviously saying it has been done, so I'd like to see that it
you
has been
claimed
done.
it didn't work,
Well,
so
the
provide your
claim was
evidence.
yours, wasn't it?
Yeah.
I didn't
You
hear that,
claimed
Redox.
it didn't work.
You just
Where is your
over-talking
evidence
everybody.
to say it doesn't work
I
in a
couldn't even hear
vacuum?
what Redox
Chemo?
was saying. Redox, you want to say that again?
Ask him where his evidence is for the claim.
Drus,
that
I'll
he
get
said
to you
it
in a
didn't work.
minute.
Where's
Not
the-
ignoring you, Drus. We'll get to you in a minute. I can't talk about this two at the same time.
Gravity keeps water on Earth
Mhm.
because it pulls things down towards the center. It's that fucking simple. If you have a ball, it doesn't flow away from the ball.
All right, let's
So
have a look
where's
at,
your evidence that it doesn't work in a vacuum?
let's have a
Chemo?
look at Drus's question and we'll get back to you, Redox.
Yeah. Where is your evidence
Mm-hmm.
that Cavendish does not work in a vacuum? You made a positive claim that says it doesn't work, not that it hasn't been tested. You said it doesn't. So where is your evidence?
I have a paper.
And I have a paper that the Earth is concave, so what? Any monk can write any paper.
Exactly. I'm going to send my
Well,
paper.
where is this paper?
And you're citing
No,
shit.
no. I want to see this paper. I've never seen a paper saying that it doesn't work in a
gonna show
vacuum,
you
and I
right
don't believe
now.
him. I think he's lying.
I'm gonna
I don't think there's any peer-reviewed paper that says it
I'm going to
doesn't
show it
work
right
in a
now.
vacuum.
Don't you worry about that.
Well, let's see it.
There
Come
you
on.
go. Bang. My peers have reviewed this, and they all agree that
Oh,
Cavendish
so
just
you lied.
doesn't
So
work
it's
in a
not a
vacuum.
scientifically reviewed paper.
That is
You've
a
got no
scientifically
evidence.
reviewed
You've done no
paper.
experiment. Good night. Thank you very much.
Okay, Redox, let's get back to your point. So what we're looking for is a reason as to why the
Okay.
water on your model...
Let's get back to the point.
Exactly.
Do you think water is flowing down the ball?
Yeah, because I asked you to show your model, and you show me a model with water.
Yeah. Why do you think that?
Well, I'm asking, how would the water stay on the ball? You said gravity. I'm like, okay, where's your experiment? You're like, Cavendish. But I'm like, well, it's never been seen in a vacuum, never been proven. You're
Yeah.
like, it has. So I'm like,
You're
okay,
like,
show me.
well, you're more like, well, hey, I'm gonna deny the basics here. because I can on the internet and no one's gonna stop me. That's what you're
Not
doing
denying
here.
anything. I'm
Talking to
asking.
you is a literal waste of time.
I'm not denying a thing. I'm looking for the
You fucking
science.
think that the water should flow off Earth like off a ball. What kind of fucking idiot would think you're citing anything remotely scientific?
I've got a map.
Said water went uphill.
I've got a flat Earth map that says scientifically and practically correct. What does that mean to you when you hear those words? What are those words?
It means that you're pretending that this is a accurate map. That's what it means.
But what do those words mean? Scientifically and practically correct.
I told you, it means you're pretending that this is the actual accurate world of a map.
That's what it
But
means
that-
to you. Pretend it.
This is just your pretense.
Okay, scientifically means pretending. Practically means pretending to you, and correct means
No.
pretending to you.
The way you use these words means pretending. I use them in different contexts.
That's what I just said. I said scientifically and practically correct. You can't beat that. You can't trump science with your belief. And again, that's one of the reasons why we are the leaders of the new school, because science supports what we say.
And who exactly are your followers if you're the leader, Kivo?
No, the leaders. There's a few of us, or a lot of us, at the forefront of this standing. Not just I.
Okay, so
You said leader.
It's just that I happen to be here while the rest of the superheroes.
Who do you lead, Kivo? Where is the
rest of the
where is
superheroes?
the tiny group of internet trolls that you lead?
The rest of the Avengers. We're saving the world, pretty basic.
Oh
You
my
can't
God.
just name anyone, not a single person you lead, Kivo.
That's a little bit psychopathy, because I saw a movie with not
Bow
socializing.
down
I'm
to
just saying that
Kibo.
there was a movie with Bruce Willis. He thought he was a superhero, and they put him in a madhouse. Glass, I think. But yeah. Anyway, what we're doing is just we're just regular people raising awareness, showing people that the Earth cannot be a globe. Obviously, we've shown Ranty last night again that water cannot conform around the exterior of an object without a force, so he knows that. Yes, and he invoked the R value at times, bringing in radius. Again, you can't go back and forth between the two ideas of globe refraction and flat Earth refraction. I mean, I don't have a model. It's going to be crazy for anyone to try and model flat Earth without full exploration. So, yeah, we've got the maps. What else do you need to know about the flat Earth?
On this map, it also has an
map.
element of
We need
time calculator.
You want to know about the sun or something? Ellipses? Got
Well,
Walter Bislin to answer half
referencing
of
this
those
map you present, there's a time calculator portion of it, it claims. And down at the bottom on either side, it has the sun solstice.
Mm-hmm.
How does that actually work?
I can get you a nearly 2-hour video that explains this map. I don't know if you'll watch it though. See? And he goes through everything. Explains the sun's
Does
speed.
it explain how it's this weird kind of oblong semicircle?
He explains everything. Australia, the size, the sun's
It doesn't
path.
take 2 hours to explain something so simple.
Like 2 hours long though, and I don't think you boarders are going to watch that. You know? So all you got to
Because
do is
the size doesn't match.
All you
That's
gotta
already
do-
been covered. So moving on to the actual sun illuminating this weird kind of oblong semicircle.
Mm-hmm.
Is there an explanation for how that doesn't match reality?
In this video, I'll get it up, I'll have to find it, but he explains all of that. They do a little animation as well, and they show how it all works perfectly on a flat plane. Quite remarkable. This is scientifically correct. You should bear that in mind.
No, it
I think
is not.
water would flow off Earth like off a ball, a beach ball.
Yes,
This
but
is not scientifically correct, Chemo. This is scientifically retarded.
Now, you need a force for the water just to be pulled to the center of the earth. Without that pulling force, there is no ball. See? How does the water stay honest if it's not being pulled?
Rotation.
And that's what we're trying to say to Bio, is that Einstein superseded Newton. And,
Incorrect. That is not accurate, and you know it.
Oh, for goodness sakes, yes, because Newton was sitting down by the tree, apple fell on
You
his head.
probably don't even know an observation
So
that
let me
was
explain how the
made
two came up
that
with the two.
actually doesn't align with the description of classical physics, as in Leibniz or Newtonian physics. Do you?
Yes, what happened was Newton sat...
What's the observation?
You're not letting me talk, are you? Just fundy muting me. Flat earthers don't have any time to speak and explain their case because of people like you, Andy. Cowbells, sorry.
Kimo, you've been given opportunity to talk on this Discord for years now. Didn't you have
never said
time to
anything?
explain relatively anything you want?
Maybe, but, you know, we still need to say more. It's not enough. We've been suppressed for 500 years now.
Well, I get the impression that you, specifically you, want to keep saying more and more.
No, for 500 years there has been different people coming forward trying to expose the globe lie, and every time they've tried to come forward they were shut down by society. So I think this is our last hurrah in this. If this generation doesn't get it right, then there will never ever be another generation that figures out that the earth is not a globe. So we are that golden age to expose space, the globe, the heliocentric model, evolution, the Big Bang, all of it. This is the time. What?
I am fairly certain, Kimo, that you imagine yourself to be a crusader for truth and justice. But that's just imagination.
I know, I don't see it like that. Again, we're just regulars. Just doing our thing, and then, you know, obviously we're presented with this fact that the earth is not a globe. So all we're doing is just raising awareness. It's not that big of a deal. It's like, hey, how are you? Do you know the earth's not a globe? What? Yeah, there's no proof, no science. And obviously we plant that seed.
That's incorrect. Everything that you present, you've been allowed multiple times to explain it, does not actually match reality.
I just tried to explain Newton and you wouldn't even let me speak.
You did not actually describe the distances. That was pointed out as wrong. When it was moved on to you to try to explain about the actual sun and the time, you didn't even do that. And you just ran away to something else that is incorrect.
Oh yeah, but I did explain. I said there's a video that explains this all. Okay. And if you want a more in-depth explanation, then obviously you can get that.
No, any explanation, because you don't have one.
What's the problem
You
with it?
haven't
What
presented one.
doesn't work here? What's your issue?
It's not my issue. It's that this observation that's being presented as scientifically accurate here on this map doesn't match reality of this weird oblong semicircle illumination upon the Earth.
Yeah, but what's the problem? What doesn't work on my...
As just stated, it doesn't match reality.
Show me reality then. Let's
It
see what
wouldn't say as is if it didn't match reality.
Right. And Cowbells, show me what is reality, so I can look at this and say, oh, you know what, Cowbells is right. It doesn't match my map here. So give us a look at your reality and show me where it doesn't pair
No,
up.
it's not my reality. It's reality. Don't even try that little nonsensical deflection.
No, any reality.
You can actually go outside and observe it, but that's a problem because you've stated multiple times you don't want to do any actual observations.
We look at the ground to see if it's curving. We don't look at the sky to give us like Earth information. No? We want to know if the ground we're walking on, is it
That's
horizontal?
incorrect, because what's the horizon?
What's the horizon? The horizon is just apparentness, not the realness.
Of what is it?
It's just like an illusion. It makes you think the sky, like the clouds, are
See, this is a problem. You're not engaging with reality. Because you know exactly what the horizon is stated as being.
the apparent.
You're not
apparent
listening to what Chemo says. It's the place where the clouds look like it's touching the ground, but we know clouds don't touch the ground.
And Kimo also
So
says
it's
that
optical.
water is supposed to flow off Earth like from a beach ball. So you might
It would.
understand that that is.
If we
not
were on a
theory.
beach ball, it would. Well, there's a practical demonstration of exactly what would happen to water on a spherical surface. It would run off like a beach ball.
Right.
Yeah, and there's another problem with it. Earth isn't a fucking beach ball. It's way more massive.
It is a ball, though.
Certainly not spherical.
It's a ball, though, and if you put water on a ball, unless you tell me what's holding the water on this ball, this is a very serious point. Show me Cavendish.
Not tell us, demonstrate.
You were told gravity, Kimo. Don't pretend like you didn't.
Right, so I said, where is the experiment to go with the hypothesis? So you have to show. You've got to
Go
show
with that.
You've got to show a pulling force with all the variables accounted for. You've never done this. Ever done this before. We've never seen it before. Never will we ever see this.
Ever. Are you gonna make an argument or are you gonna just repeat ever like an idiot?
Just so it sinks in that nobody has never seen Cavendish in a vacuum. Never.
I got it. You're gonna keep repeating ever.
No, not repeating. I'm just saying it sinks in that nobody ever has never seen Cavendish. Never. That should be a problem for you. That ever no one never has ever seen Cavendish in a vacuum.
Well, it's about to be a major problem for you with Biodual
I just came back to the
doing
room.
this
Who
thing that
broke
he's doing.
Chemo?
Honestly, have no fucking idea which disorder causes this sort of speech slur.
Well, go on then. Provide it then. Let's have a look at your experiment. Oh wait, you can't because no one's ever seen this.
Who broke Chemo?
How embarrassing!
You're gonna have fun here. How long is it until Biodual does this thing?
How
soon
you
is
see,
that?
everyone's waiting for Biodual, as you should be, because it's never
No,
been done
not
before.
everybody. Just you.
What's Biodual doing?
Biodual is going to be the first person ever to at least attempt to show it online. And obviously, you know, if we get that force, that pulling force, the whole entire community will be like, whoa, that's cool.
Show what?
Yeah, so there'll be no flat earthers left.
No, but what is he showing?
The pulling force. You see? No one's ever seen or observed a real pulling force. And without that pulling force, your model that you provided...
No, because it's not a pulling force in the way you're describing. It's a force of attraction.
Well, we're getting conflating arguments because half of you are on Einstein's side, half of you are on Newton's side, and you know it doesn't matter
That's
to us.
incorrect too.
Either
because
way,
you don't understand how Einstein supplemented Newtonian and classical physics.
look,
Superseded is what you mean.
Yeah.
Subsumed.
No, superseded is not at all the correct term.
Anyway, I'll be back.
It is.
I'll be back. Be nice to Sala.
They're not even remotely compatible because the one asserts that mass is doing the cause of the effect, and the other is that the mass is bending space-time, and then the space-time is pushing the mass back together. So they're completely antithetical. They're opposing. It's not the mass that's causing something any longer, just a simple attraction due to mass. It's the uneven distribution of the mass on said space-time, the fabric of space-time, which is causing a distortion in the fabric, which is therefore manipulating the mass together, which is exactly not compatible.
Except for the equation that Newton gave us, the relationship between the mass and the distance is completely derivable from the field equations in Einstein. The underlying mechanism they talked about, the paradigm with which it's actually happening underneath the hood, it's different, but you can get all Newton's equations directly out of the field equations from Einstein. So they clearly one is subsuming the other.
How do you exactly do that you state that under Einstein it's described as the mass causing the actual distortion in space-time, and then just blatantly go on to a conclusion that it's not the mass?
You obviously didn't understand what I said.
Oh, I understood exactly what you stated, which was at first correct, but then you jump to this conclusion that somehow it's not the mass that is actually a cause.
Is it the space-time that's being bent that's causing mass to ball up into spheres?
And
Or
what
is
did
it
you
purely the
say was
mass
causing the
of said
distortion in
object pulling
space-time?
itself in?
What did
Yeah,
you
but do you
say?
understand that that's circular reasoning? The mass causes a bending in the space-time, and the space-time causes the bending in the mass. That's circular logic.
That's probably because that's not what's described as space-time bending mass.
The uneven distribution of mass causes a distortion in the space-time, the fabric of space-time, thereby creating these said orbits, because it's the space-time that's bent doing the effect. It's not the mass, simply on the fact that it has mass causing that effect. I understand that you're trying to link me to the point where I said it's the uneven distribution of the mass on this imaginary space-time, that now you're linking it back to the mass, but it's the space-time bending or it's the mass attracting. It can't be both. And if either could actually be demonstrated, like what Kimo was saying about the Cavendish, that would also take it up another notch. But it's all speculative. Assumed to be. Because can you show me space-time? Can you give me a jar?
Yeah, have you not seen an Einstein ring?
An Einstein ring.
Yeah.
That's not familiar to me. Maybe elaborate.
I'll post a picture for you. What do you think is happening in that picture?
Oh, I know. I know. Pick me.
Go ahead. What's happening?
Who's posting a picture?
Jake, I just posted the picture.
That's called.
And then here's an article about how it was used to predict the supernova, which is not a predictable event.
I don't see how this is relative to a bending of space-time or proving that space-time is there.
You understand that you are literally looking at warped space-time in that picture.
Incorrect. I'm looking at a light phenomenon, supposedly or purported to be. It could be space-time or it could be other phenomenon. We cannot go there to actually validate.
I do find it interesting that Solar is effectively saying that positive feedback loops don't exist with his whole idea. That is a straw man beyond straw man to begin with.
Positive reinforcement loops and reification are a very fine line.
Well, not really.
Or begging the question.
There's no begging the question.
If
It's a
if
positive
P
feedback.
if P then Q, if you say if P then Q, Q therefore P, that's a fallacy.
No, not
So
necessarily.
if you think because of a
No,
space
it's the
time,
same
I see a
formulation as
picture.
modus
The
ponens.
picture proves space time. That's circular logic.
No, no,
P
it's what you're
equals Q. We do find P, therefore Q is accurate. That's the real logical way to
Solar.
look at that modus tollens.
Flutter Solar. What else do you know from modal logic besides P and Q? You're citing modus tollens here. Can you cite modus ponens, for example?
That's what I just did. If P then Q, Q therefore P would be the modus ponens, which is the fallacious reasoning. But
No,
if
it's
P
not.
then Q, we do
only
see
fallacious.
P, therefore
It's not
Q,
fallacious.
that's logical reasoning.
You're so silly.
So how do you address about R and S and T and V?
Now, to be a little more accurate about the Einstein ring, it was observed before it was made an Einstein evidence thing. It's the calculation of the displacement that is the Einstein evidence.
Right. The fact that in that article, if you look in that article that I posted, how it was used to predict a supernova,
It's
they were
all
able to
assumption
use that
based.
displacement of light to be able to predict when it would reappear again.
It's
Yes,
all
that is-
assumption based, and it's
No,
often
it is not
CGI.
assumption based because it works. So it's literally established that it works. So it's not an assumption.
So you're literally getting nothing right that you're saying. You know this, right?
Incorrect,
No,
because you guys are
correct.
saying, I see a picture. I could show you a picture of a unicorn, and that would prove that unicorns exist. That's what
I
you
mean,
guys
you
are
just
basically
went on-
doing right now.
You just want an
Here's,
extended speech. You
here's
just
a
want an extended
picture of a
speech telling us-
circular line
You
of
just
light.
told us that
and
modus
that
ponens
proves space
was
time.
something that it's not, and then you told us it was a fallacy. It's like you have no idea what you're talking about. It's crazy.
I described exactly modus ponens.
No, you didn't. What do you think modus ponens is? Say it again.
You see, you weren't listening.
I was listening. I want to hear you say it again because I want to hear you tell me it's a fallacy. I'll tell you what it is. It's if P then Q is one statement and P is another statement. The conclusion is Q. That's modus ponens. It's the inference rule.
It's if you see the inference as your proof. So if you say P equals Q, then you see Q, therefore P.
No, that's tone.
No.
That's tollens. That's modus tollens.
Tollens
No.
of a not Q.
Ponens is if P then Q, P then Q. So that is the inference rule. Ponens is inference rule. It's not a fallacy. It's a piece of modal logic. It's straightforward. You're getting it mixed up with. I think you're getting it mixed up with tollens. Tollens is if P then Q, Q, and then the conclusion of P is can't be made from that.
So modus ponens is a much more basic thing than modus tollens. Now, if you're bitching about modus tollens, shouldn't you at least have the basic fundamentals to understand modus ponens, Solar?
That's exactly what I
don't
said.
you fucking know
What is it, dude? Just look it up, man.
The modus ponens, if P, then Q, then if P holds, the consequent Q may be inferred.
Yeah, yes, that's the opposite of what you said before, though. And you said it was a fallacy, if you recall, and it's clearly not.
Let's
But
cite
it's an
some
affirming the
mathematical
consequent.
logic terms and pretend
No,
we
it's a
understand
freaking
mathematical
antecedent.
logic.
Jesus Christ, dude, you're just completely clueless on this topic. This is not
I mean,
something you
for
should be
Christ's
speculating
sake, just fucking Google this shit. Can't people use Google
on. I don't
anymore?
know. Like, what is your background? Are you a mathematician? I mean, you're clearly not a mathematician, but where did you learn this stuff? Because you're reaching back too far and you're misremembering. You just need to refresh, I think.
If I had said it incorrectly, then it was a slip of the tongue. It is something that I've looked into, all these fallacies and
They're not
rational,
fallacy. It's not a fallacy.
logical reasoning.
You see that most opponents is
Um,
not a fallacy, right? That's just basic deductive logic, right? If you have the inference, which is if P then Q, and then you know that P is true, you can legitimately conclude Q. That's not a fallacy in any way. That's just straightforward logic.
Yeah, this is basic logic. I mean, why is that a fallacy?
It's not. It's not. So here's an interesting quote from Einstein that I was just looking up for you. I'd heard this before, but it took me a while to find what it is. This is Einstein talking about Newton. Many people think that my theory of relativity is overthrowing Newton. This is not true. No one must think that Newton's great creation can be overthrown, not in any real sense, by this, the theory of relativity, or by any other theory. His clear and wide ideas will forever retain their significance. They are the foundations on which everything that I have built stands. And there's also this. Newton's law of gravity is one of the gems of modern science. The theory of relativity subsumes it, and it has not displaced it for any practical purposes. So,
subsumes or supersede.
Subsumes.
It means replaced.
No, subsumes
it
means
doesn't
absorb.
mean to refine.
Subsume
doesn't
means
mean
to incorporate.
improve.
Subsume means to incorporate, to absorb, to envelop. It does not mean to replace. It does not mean to destroy it. When you subsume something, you take it in and then you add on top of it.
Yeah, the one thing that you do have from Einstein is that whole gravity is not a force; it is an effect of space time.
These are just paradigms, though.
That quote though ends in it is observed as acceleration. So it comes right back to what Newton said. It is observed as acceleration. I don't know why, but it must be caused by a force. That's what Newton said.
It is a force. It's just not a force in all frames of reference.
Yeah,
It's not caused by a force. It causes forces, but it's not caused by a force.
It's a force by definition.
Yep.
The consequence
I do find
is
it
a
interesting
force.
that solar. I do find it interesting that solar is latching onto this term superseded, like it didn't come from one person who wrote an article, and the article says that Einstein didn't supersede Newton in total. He just superseded it as the best description of gravity.
Oh yeah, okay.
It's not what that's
That's not even
literally where
saying,
the
yeah.
entire argument comes from.
I see. Well, I mean, but again, I just read you a quote from Einstein where he literally uses the word subsume to describe what he did.
Supersedes bullshit comes probably from idiots who don't understand the basic Newtonian mechanics and want to pretend that let's ignore it because we have relativity now.
Oh yeah, that was Quantum Eraser's argument for a while. Is that well, now that we have Einstein, you can't use any of the Newton equations. You have to derive all mechanics from Einstein. Therefore flat Earth, which was about the dumbest argument he's ever created.
Well, ironically, there are people that go on and on about reification, and the only real example of reification I've ever seen anybody do is when people try to take theory of relativity or they try to take Newtonian mechanics and they reify them into these things that are mutually exclusive, these physical realities of like force and curvature of space-time, as if those aren't things that are describing behavior. If you think about it, a force is not something that exists exactly. A force is a way in which we talk about how objects move, how objects, how motion works. It's not like force is this, I don't know, noun that exists out there that we, spotted one day. It's a paradigm.
You think force is not a noun?
A concept, though. This goes back to a deeper understanding of science. You don't know the basics. I don't think you can explain that, Scott.
It's true. it is a more subtle sort of description of it, but it is a noun, of course. It's technically a noun, but what I'm trying to say is that it is something that we invented as a way of talking about motion. Like
I think I said what you said to multiple flat earthers, but it flies over their head like some random words. They just don't fucking get the concept. They don't get the concept that this is a concept, so to speak.
Right.
Aren't you talking more generally about language there, Scott?
Yeah, or language and just the truth of the underlying truth of what these ideas are in science. Like when you really get at a deeper understanding of what we're saying when we say these things, I guess I'm trying to get at. Because a lot of times people shorthand this stuff as if it's like literal,
Well, that's what we do generally with language. I mean, language we use to try and communicate our experience or something we observe.
Yep. Like I guess there's a different to me. There's a difference between saying mass or saying volume. These are sort of physical things, and what we mean when we say where the idea of a force came from and what we really mean when we say that. To what extent is a force a literal reified thing that exists out in the universe independent of us?
Well, you've got to be more specific. Are you asking about what is causing the effect?
I think to address what you said, Rams, yes, when we talk in normal language, we use words and phrases. But when you want to talk about a subject, you have to know what these phrases actually mean within the context of a subject.
Yeah, sure, of course.
Because what I'm getting at is that, force, really when force is we have this equation, right? We have Newton tells us what force is, mass times acceleration. And so it's really a way of talking about mass accelerating. And that's it. So mass accelerating, which is more of a process than it is a thing, as opposed to say mass. Mass is a thing, but force is more of a way of looking at how motion, it was a way of talking about the way in which things move.
Yeah, it's quite annoying how the inherent vaguenesses within words that we use to engage in concepts as a means of convenience,
Yeah.
inherent vaguenesses are purposely being used
Yeah.
to try and disprove the entire concept, such
Yeah.
as trying to claim that, Einstein superseded Newtonian.
Or natural means not man-made, and so anything man-made can't be used in science or whatever.
It's only annoying if you take them seriously.
True. The number of flat earthers that have told me that a word only has one meaning. I find it so jaw-dropping that anyone with over the age of 8 could think this. It's just crazy to me.
Yeah, that's absolutely astounding that people who rely on words have multiple meanings would tell you that they only have one.
Especially when you would be hard. If I challenge you to find me a word out there that only has one sense meaning, you'd have a really hard time finding one. Like almost every word has multiple sense meanings. Like I'm not sure I know of a word that's only got a single meaning.
This is so much quantum eraser style thinking, though, isn't it? I think.
Four. The word "for" only has one meaning.
Which four are you talking about?
Well, that depends.
Yes only has one meaning.
Yes, could be the name of a band. Remember, Yes, they were a good band. Prog rock.
Or banana, orange.
And sometimes yes means no, obviously, and sometimes come on, yes means all kinds of things.
Was that your defense in court, Scott?
My defense was no. My defense was no means yes. The other way around.
How many uses of the word penis are there?
A lot. There's obviously the literal medical one. There's the insult.
Yeah, like you're a complete penis moyock.
Well, yeah, but that